So myself, Nikunj Gevariya. I'm a PhD student with the Dr. Van Safradet. My apology for my French. I have to do it in English. So I'm presenting my project called Develop the Mental of Urine-Based Inflammatory Test for Prostate Cancer. Let's look at what the prostate is. The prostate is a gland located just below the bladder. And anterior to the rectal wall, and the urethra just passes through it. It secretes the fluid that helps the sperms to move and migrate. So it's an essential male reproductive gland, but the cancer in this gland is a major problem worldwide. How big is the problem? Well, it's the third most diagnosed cancer in the world. Talking about the diagnosis, there are three main tools that are being used for the clinic to diagnose the prostate cancer. First is a PSA called prostate-specific antigen that is being measured in the blood. If the patients have a higher PSA, they are recommended to undergo digital rectal examinations. So in DRE examinations, the clinicians look at the stiffness of the prostate tissue via rectal wall and see if there is some abnormalities. And if they found some abnormalities, the patients are recommended to undergo biopsies. And these biopsies are analyzed histopathologically to grade the prostate cancer. Now, there is a scale of 5 grading actually. So under a microscopic view, each biopsies are looked for the cellular differentiations, and if the cells are well differentiated, they are assigned as a glycerin grade 1 to the scale of 5. If the cells are poorly differentiated, they're assigned as a glycerin 5. And this kind of grade is assigned 2 times within the biopsies. That leads to a development of glycerin score. So the glycerin score actually goes from 2 to 10. Now that's the way we grade this cancer, especially the glycerin score having 6 is a low-grade cancer, and if the glycerin score is 8 or above, it's called as a high-grade cancer. Now, it is an excellent method to grade the prostate cancer and to manage in the clinic, but it has a major disadvantages. First of all, it's an invasive test. Secondly, most of the patients that are diagnosed with a low-grade prostate cancer, this cancer in these patients is indolent cancer. What does it mean? Well, these patients not gonna die throughout their lifetime because of the prostate cancer. So we don't treat these patients with any radiotherapy or chemotherapy. These patients are recruited in active surveillance, and these patients are monitored repetitively. So they have to undergo repetitive biopsies. So that leads to an anxiety and discomfort. And each year, the cumulative number of the patients in clinic having low-grade prostate cancer are piling up. That leads to quite a lot of burden in terms of time and money. Now, with the advancement in all technologies going on in healthcare science, I think we can do better here. First of all, we have to develop some test that is non-invasive. Now, for non-invasive sample, urine that is collected just after digital rectal examination called DRE urine would be an ideal sample, because we already know that some efforts has been done to develop PCA3 kind of test. There's not much of clinically successful, but if you think of rethink of the cancer, how many systems we can really track there? Well, there are so many systems that are dysregulated in case of cancer, but what we think would be most important would be an immune system. Why? Because if you look at this tumor microenvironment in the center here, in tumor microenvironment, these cancer cells are accompanied with the other cells along with the immune cell and inflammatory cells. And what's exactly going on there? There's a fight going on there, right? So if the immune cells kills the cancer, there's no cancer. It's going to eliminate the cancers. But we know that it's not the case always. Cancer cells escape this attack and maybe develop an equilibrium stage where kind of a case the indolent cancer in the prostate. And again, it's possible that these cancer cells undergo multiple mutations and it escape the immune attack and become a really aggressive cancer, and patients possibly die because of it. So what we think is that all the cells are communicating each other with the cytokines and chemokines and inflammatory proteins. If we can track these proteins in the urine, we can define this stage, and it could lead to a development of a test that could be either equivalent to the glycerin grade or even better. So to that, we have two objectives in this project. First is to see if the DRE urine that is collected just after digital rectal examinations is enriched with the prostatic fluid or not. And if it is, then look at this urine for the different grade of the cancer patients and see what kind of protein signature is there. So to do that, we use some advanced technology where protein in the urine are digested into the small peptides for the mass spectrometry, and these peptides has been separated by the column chromatography, and then these peptides are injected into the mass spectrometry. Now, what the mass spectrometry actually does is that it assigns each peptide's specific mass to charge ratio, which is specific for each peptides, and that's how we can quantify the protein expression. For clinical samples, how we have collected? We have collected the pre-DR urine. That means the urine collected just after digital rectal examinations, and we have collected another urine sample after digital rectal examinations. And we have collected this urine from different grade of the cancer patients and also the non-cancer patients. We have analyzed them with the mass spectrometry, as I showed you in the previous slide. In each sample, we have detected around 400 to 500 sample proteins. And if you look at the abundance of these proteins in post-DR urine versus pre-DR urine, we found like 74 proteins were more abundant in post-DR urine. And these are the top 15 of them, and you can see that the PSA and other two cancer that are the proteins that are already known in the literature. They are about 13 to 28 times more in the post-DR urine, which leads that this urine is actually enriched with the prostatic fluid. Now, the second objective was to look at these proteins in the cancer versus no cancer patients. So we looked at, and we found in the low-grade cancer patients, these are the set of proteins that are upregulated, and these are the set of proteins that were downregulated. And we have found separate set of the proteins that were up and down regulated here. And especially if you, here in this box, you can see these proteins have been already reported as a prostate cancer marker by another terms, I mean, not in the urine, but by directly looking at the tissue. So the approach that we are using is seems that we are going on the right path. So with that, altogether, I would like to conclude with the results that the post-DR urine is enriched with the prostatic fluid. It's an ideal sample to develop a non-invasive test, and the signature that we found is being correlated with the literature, so it has a potential. But the key limitations, though, we wanted to see some of the IL-6, IL-8, or GM-CSF, the key cytokines and molecules that define the immune response again. They were not detected in the urine sample. So one of the possibilities is that their amount is very low, so the sensitivity of our assay is not that high enough. So what we are doing next, instead of looking 400 and 500 proteins and do the discovery proteomics, we're going to restrict to the 50 to 60 targets, which is called MRM assays, and which leads to an 100-fold more sensitivity. And we'll define a signature, and we're going to validate with the more number of the patients, as we are right now. We are collecting the samples with the more number of the patients. With that, merci beaucoup for your attention, and I'll take the questions. It's my team.
Have you validated how to actually get your urine sample? Is it first voided urine after the DRE?
Yes, it's first voided urine after the DRE.
And how much urine are you collecting?
Volume? Well, the volume actually varies from patients to patients. It goes up to 5 to 15 mLs or 20 mLs. But for the mass spectrometry assays, we need like in microliters, so it's quite enough to do the assays.
Like just that you're going to wash the prostatic urethra with that first voided urine. And if you get 50 ml urine, you're going to have a very diluted volume.
Yeah, that could be the case. It can be very diluted, and it could be the reason that the cytokines that we want to detect are not we are not able to detect because of the sensitivity and the low abundance of the protein.
And in your validation, have you explored the fact that some patients might have had some sexual intercourse the night before, which could significantly influence the secretion of prostatic fluid?
That could be, I mean, that's a nice point though, but in this study, we didn't include that kind of strategy to exclude the patients. Here, what we have excluded the patients based on the inflammatory profile, if they have found as inflammations or the enlargement of the prostate, we have excluded from from that, but that could be a nice strategy to keep in mind for our further analysis. Yes?
I have a rather naive question.
Yeah, go ahead.
With the digital rectal exam, the exam in itself, does that produce secretions from the prostate that would then be in the urine that you're collecting after the exam?
Yeah, exactly. Because the urethra just passes through the prostate, and actually prostate secretes the fluid in that duct. So what we think is that during the digital rectal examinations, it actually the clinicians squeeze the tissue, prostate tissue, and see if there is some abnormalities. So we think that all the proteins that are already there, stagnant, go inside, and we really see that urine that is collected after digital rectal examination has prostate-specific proteins that are 30 times more. So in normal urine, there is a PSA, there is a prostate-specific proteins, but after digital rectal examinations, they are just 30 times or 20 times more. So we think that there is a more chance to detect cancer with the DRE urine. Yes?
I just see in your procedure, so you prepare sample for mass spectroscopy, you digested the protein into peptide, is that correct?
Yes, we have to digest the proteins into peptides because mass spectrometry cannot work with the larger molecules.
How you detect it the peptides, how accurate you can reconstruct those peptides back into the original proteins. You have so many proteins mixed, and you have all the peptides digested mixed. How accurate you can reconstruct those peptides back to the original?
Yeah, so that's excellent question. Well, the proteins are digested into peptides, and this peptides has been analyzed for the mass to charge ratio, and then computationally they are compared with the database. I mean, it's a computer model, so there is a false discovery rate there. But that's why there is another method that I call MORM assays, in which we already inject the heavy labeled peptide within the sample, and then we run them. So we exclude the chance of discovering false peptides. And we have to do in 2 steps to not to discover false positive results.
Are these ratio of false positive higher or lower than the presence of those singles you want to detect? Because those secreted singles want to detect those specific proteins level, they are might be very low. The ignorance, your false positive, false negative single might be higher than that.
Yeah, that's true. The first method that is called discovery proteomics, in which we look at 500 or 1,000 proteins, it has a chance. But once we will know which are the proteins that are going up and down, and we choose 50 targets, then we will know, there won't be any chance to detect false positive after that. So when you want to detect like broader spectrum discovery proteomics, you have a chance that you will have something that is discovered as a false positive. But in the second step, when we synthesize the heavy and light peptides and we narrow down the range to 50 to 60, then you will in the second step you will know that the first step possibly few targets were false positive or not. So that's the 2-step strategy that we can, that's the way we can go. But in clinic, it's going to be the second step. We know 50 targets. When we repeat the experiments in the clinical, we are sure that it's going to be MRM assays, so there won't be any false positive discovery when we translate in the clinic. Yes?
More or less the same question.
Same question.
Why do you need to digest?
Well, why we need to digest the peptides? Because it's a limitation of the mass spectrometry. We know that the mass spectrometry was being used for the clinical chemistry, but now with the advancement, we can use for the larger molecules. And now it's possible that we can work with the peptides, which is around 10 to 20 amino acids long. But larger it's become, you cannot charge a protein, and we cannot run in the mass spectrometer. So we have to work with the peptides, but I think in the future we will be able to, without digestion, we will be able to run full protein and do it. But I think it's far more, much more to how the mass spectrometry's limitations. Merci beaucoup.